Welcome to this eLearn Security video training lesson on Nmap. In this video, we will see how we can use Nmap to find ports and services running on our target machines. Nmap stands for Network Mapper, and it is one of the most popular and widely used network discovery and security audit tools. Some of the most common usages of Nmap are the port scanning and host discovering. Although Nmap can be used for different purposes, during our penetration testing process, in this video, we will focus on the port scanning features. Before running any scan against our targets, let's take a look at the Nmap's help guide. As we can see, a very big list of options and techniques are available. We'll explore some of them during this video. By now, you should already know that one of the most efficient, fast, and stealthy scanning methods is the TCP SYN scan or half-open scan. With Nmap, we can perform a SYN scan by adding the -S argument. Please keep in mind that if you run the scan in a local area network, Nmap performs a few more operations before actually running the SYN scan. Firstly, an ARP ping scan takes place, then a DNS resolution of the target, and then the actual TCP SYN scan starts. Nmap does this because it's the faster way to find live hosts in a local area network. Notice that we can change this default behavior and instruct Nmap not to run an ARP ping scan by using the -- disable ARP ping option. Moreover, we can tell Nmap not to run a DNS resolution by adding the -N option. Let's see these examples in action. Firstly, we open Wireshark and set a filter to only show the DNS or ARP packets. We do this because we want to see how Nmap default scan works on the network. Then, we go to Terminal and execute the basic SYN scan by specifying the -S argument followed by the target's IP. Here, we also add the -D parameter to enable the debugging mode. Finally, to limit the output size, we also specify to scan only port 80 by the -P parameter. At the very beginning of the Nmap output, we can see that Nmap initializes an ARP ping scan to see if the target exists in the network. This option is pretty fast, but we don't need it, as we've already uncovered the network hosts on the host discovery phase. After the ARP ping is completed, Nmap performs a DNS resolution against the target IP. This might be useful on external hosts, but we do not need it here, as it will take longer for the SYN scan to be executed. From the Wireshark traffic capture, we can indeed see that Nmap performs an ARP ping scan and a DNS resolution query. Although the scan may seem very fast, we can make it faster by disabling the DNS resolution. So let us use the same command, but this time, let's add the -N option to avoid the DNS resolution. We can also add the -PN parameter in order to treat the target as online, without checking whether it is or not. As you can see, there are no DNS packets in Wireshark. The options we just disabled will have a bigger impact when scanning a big range of hosts and ports. Let's see the time difference with a couple of examples. We'll speed up the video in order to see only the results. First, let's try to run a default SYN scan. We will just set the scan type. As you can see, it takes 55 seconds to complete. Let's now run a similar scan, but this time, let's disable the DNS resolution and add the -PN to disable the ping scan too. As we can see, the time difference between the scans might be important during a real penetration test, where the time is limited. Another port scanning technique that Nmap offers, and that should be mainly used when the SYN scan is not an option, is the TCP connect scan. Different from the one we just saw, this scan creates a full connection with the target machine. This time, instead of writing raw packets which require root privileges, Nmap forces the operating system to establish a three-way handshake connection with the target. Before running the scan, let's go back into Wireshark and set the correct filters. We want to see only the packets that have the SYN flag and the ACK flag set. To execute a TCP connect scan, we can use the -S parameter followed by the IP of the target machine. Here, we also add the -F option, which tells Nmap to run in fast mode. In other words, it will scan fewer ports than the default scan. Like for the SYN scan, we can use the same options used before, so we can run the scan on a specific port or a port range. For now, we will run the command without specifying any of these, except for the -F option. From the Wireshark output, we can see the 3 packets we have received. All of them are SYN-ACK, indicating the ports as open. Another scan that we should usually run during our penetration tests is the UDP scan. The UDP scan might be slower, but it is the best way to find UDP services running on the remote systems. To execute a UDP scan, we can use the -SU, as a scan like this will probe all the 1000 ports. We also choose some specific ports to scan. As usual, we have to add the -P option, followed by the ports we would like to scan. Before running the scan, let's go back to Wireshark and change the filters in order to display only UDP traffic. Now that the filter has been applied, let's go back in the terminal and run the scan. An open port listening on UDP will reply with a UDP packet. ICMP error packets instead indicate a closed or filtered port. As we can see, from all the specified ports, only port 53 is accepting UDP. And indeed, we get a UDP response. In the bottom panel instead, we can see more details about the packet sent. So as we can see here, the first 4 packets have been sent to closed ports, while the 5th packet has been sent to an open port. The next port scanning option that we're going to see is called TCP null scan. This option sends TCP packets with none of the TCP flags set. To execute this scan type, we replace -SU with -S_N, and we will use the same ports again. Nmap indicates the ports as open or filtered if no response is received from the target. While if a reset and acknowledge flag is received, Nmap considers the port closed. Let's inspect the traffic in Wireshark and set the filter to display only the specific communications with the target. As we can see from Wireshark, we received the reset and ACK flags from every port specified except for ports 80, 53, and 21. This indicates the ports as open or filtered. The next 2 scan methods we will see work similarly with a null scan. A closed port should reply with a reset and acknowledge flag, while open ports do not return a reply. The first scan is called Christmas scan. Christmas scan is a combination of the fin, push, and urgent flags. It's called Christmas scan because when we combine them, it's like they light up the packet as a Christmas tree. To enable the scan, we have to use the -S_X option. Moreover, we will tell Nmap to scan the most common TCP ports by using the --top ports argument, followed by the number of ports we want to scan. In our case, Nmap will take the first 200 ports from its most common port list. Again, in Wireshark, we can see all the reset and acknowledge packets coming, while this time, our requests have the fin, push, and urgent flags set. If we go back in our terminal, we can see that another open port has been discovered, port 5555. The last scanning technique, similar to null and Christmas scans, is called fin. Fin scan is a scan where only the fin flag is set. To enable this scan, we just have to specify the -S_F argument. From Wireshark, we can see that all the requests contain only the fin flag, while again, all the closed ports reply with an RST and ACK flag. As you've seen, depending on the technique used, Nmap may set different flags in the packets. If we want to set arbitrary flags on the packet sent, Nmap gives us the ability to do this. We just have to specify the --scan flags option, followed by the flag name we want to set. In this example, we set the urgent flag in order to scan the target machine. From Wireshark, we can see that only the urgent flag has been sent. Nmap's a very powerful tool that we can use during our penetration testing phases. We just scratched the surface of its features, but thanks to its huge amount of options and configurations, we can run very specific and powerful scans and network analysis. We suggest you practice different scans and options in order to become more familiar with Nmap. Thanks for joining us.